Shut up and sit down.
Well, hello everybody, welcome. I am KiteCraft, and welcome to Project Night. So tonight, we are looking at this. Sorry, I just gotta make sure I'm in my camera. Tonight we are looking at this drill press, a miniature, a 3D printed miniature drill press. It is in fact a precision drill press, and I'm quite happy with this design. This is my second design. The first design, if you go back on my YouTube channel and have a look, you'll see it, it's up there. And it was quite good, and I'll talk about that. Then I made this one. This is primarily for drilling holes in printed circuit boards. If you're going to make your own circuit boards at home, you know that that's a lot of work. Drilling all of those holes, you need something that's going to be reliable, easy to use, simple to change bits, comfortable, accurate, and you can buy tools, sure, but what's the fun in that? My motto is, if you need a tool, make a tool. So I made this drill press, and it's actually, I'm quite happy with it. Let's have a closer look at it. Hopefully you can see it here. So everything is about 3D printed except for these particular shafts on these uprights. These are carbon fiber tubes, and these are carbon fiber rods, and they're the secret behind this. I had some requirements when building this drill press. What I really wanted was a drill press that was going to be smooth action. I wanted something that was going to be not hard or a lot of effort, something that was going to be smooth all the way through, something that was going to be no slop, no play in it at all. It had to be PWM controlled, and you know, it took a lot of work and a lot of variety, and I finally made this. And so I'm here to tell you about how you can make this yourself. It is available on YouTube or on Thingiverse. The other thing is this video, it primarily is also a training video for me to figure out how to go about doing this. And I seem to be forgetting a particular thing because I don't have my notes with me. So that's number one. Nice. Now, this configuration that it's in is capable of using a much longer drill bit, as you can see. But as I said, this is meant to be used with. This is primarily meant to be used to drill circuit boards, and that uses actually very small drill bits, like 0.5 millimeter. There. So this is a number 68 drill bit. Let's use that. Taking the drill bits out. These are really small drill bits. As you can see, if I put that in my hand, I'm sure you can see it. So when you're drilling with these types of drills, when you're drilling holes with these types of drill bits, your regular floor drill press is not going to cut it. And in fact, even a Dremel isn't going to cut it, because you don't want to be drilling all of these holes by hand with a Dremel. You do need some other tool. And the previous drill press used a Dremel, but it used that hose that comes off the Dremel, and it gives you that smaller handle. But the problem there is that I had to keep removing that handle from the press in order to change bits. And I definitely don't like doing that. So with this new one, you can actually just change the bits right on with the collet. Now, caveat number one, no matter how well you build this and how awesome the action is and how stiff it is and there's no play, overall, your accuracy is going to come down to this collet and your motor. If your motor isn't really spinning straight, then you're screwed. And if this collet isn't really balanced right or spinning well, or if it's not straight, it's going to cause your drill bit to wobble. And there's really nothing you can do. You know, the best drill press in the world won't make up for a crappy collet. And I'll show you where you buy these on eBay, and I'll tell you right now, these are cheap. They're, first of all, inexpensive. Second of all, they're just poor quality. So I'll give you a tip: when you buy these, you're going to want to buy a lot of them, just so that you can mix and match and try and find one that spins the best with the least amount of wobble. That is a little bit crazy. Overall, the bed drillable size is. Got my camera in the right direction. I got the proper light that I need on it. Sorry. I hope that's a little better. The bed is just about 13 centimeters wide, about 12 and a half. And then you can go from the uprights out, we're dealing with about 15 centimeters. And then we have this guide. I forgot my drill, I forgot my screwdriver. So this drill press does in fact have a guide on it. Oops, I did have the right one in the beginning. So you can move the guide back and forth. Sorry, I know I'm trying to do all this at once and I'm still learning, so I'm not talking right. And there we go. We have a fully adjustable guide on here. That way, when you're drilling multiple holes in a circuit board, especially when you're dealing with those big long chips that are 20, 30 pins on a side, you need to be able to drill a whole bunch of holes in a perfectly straight line. So that's where the guide comes in. And as long as you've properly sanded the edge of your circuit board to be perfectly parallel and at right angles, then you can use that guide to drill all your holes. Okay, all right, nobody's chatting, so that's good. Okay, you know what? Put this on here. Now, let's go ahead and spin her up a little bit. You'll notice this has a plug on the end, an XT60 plug. That's because this is totally portable. Not only can I run this off of a local power source, for example, this is my local power source. I'll undo the cable here. This is 12 volts output. So I can run it directly off of here. So you can hear the fan kicking in. Drilling a lot of circuit boards, there's a lot of dust that gets blown around, so it probably gets filled up with dust, and it's just probably a crappy fan. Yeah, that always works, right? Just ding it. Now, like I said, I can run this locally off of a 12 volt source, which is exactly what's happening here. But this is, in fact, a portable drill. So when I want to take this out to like a hackerspace or somewhere else, instead of taking the bulky power source, I can in fact just take a battery. Plug this in. I don't think my battery's fully charged, but I can run it directly off of that. This is a PWM motor controller that I'll show you guys. So you have full control over the RPMs of the motor. Slow, fast, very fast. This is a direct drive 380 motor. It's got more than enough RPMs to do the job for any drill bits you want. It really does. It has enough torque that when you drill in the circuit boards nice and slowly and gently, you're fine. Now, there's enough space on here for you to drill out a big 2.5, even 3 millimeter, like an 1/8 inch drill bit. You can actually fit that in here with just enough room But if you try to take like even a 1 or 1.5 millimeter drill bit and try to drill a hole in a block of wood, you're not going to do it. Not with this particular motor. But I didn't need to do that. That's not one of my requirements. I did make it so there's enough upgradability that if I want to do that, that's not a problem. But to do that, all you'd have to do is make a new bottom arm and a brace, and I'll show you how to do that in a minute. And the only important bit is in Fusion 360, and I'll show you, is just that the hole in this is above the hole in here. And you can have any size motor that you want, and I'll talk more about that in a minute. But first of all, let's go drilling some holes. Now, it can actually be, there, I don't know, is that lighting good? I hope so. Okay, there we go, good enough. It can be actually kind of difficult trying to get your drill bits in here all the time, because when you're dealing with these tiny little drill bits and the size of the collet that's actually in there, it's very hard to have things line up. Oh, by the way, if you haven't noticed, the additional collets can be stored right here on top. Now, like I said, it can actually be a pain in the neck to try and get these tiny, tiny little drill bits to line up inside those holes or inside that collet. So instead, what I generally do is I'll take out my drill bit, make sure I don't lose it, get my little Allen key, and I'll actually just take this off. It's got 2 screws on it, 2 set screws on it, one on each side, and it just slides right off. So that's the collet. Let's give you a good look at the collet here. Now, you can buy these on eBay, and I'll show you the link in a bit. However, they aren't the best quality. So when you buy these, they're for a 2mm shaft, and these motors, these 380 size motors, are a 2mm shaft. So these fit actually really well on any of these 380 size motor with a 2mm shaft. They do fit really quite well. However, they are low quality, and instead of just buying one, you're going to want to buy half a dozen so that you can mix and match. I bought a couple, and one of them wobbled so bad it actually started to shake the whole thing, and there's no way you could drill with it. This one seems to be the most accurate combination. I put Teflon tape on it. I'm so sorry. As I was saying, you want to buy at least half a dozen of these so that you can make sure you get at least one, and maybe take the parts of one, like the base from one package, and this bit from a different package, and the collets from a third, and make sure that you actually get one that's going to work well for you. Now, I put Teflon tape around here just so that I could get rid of just some of the slop that was in this. If it wasn't tight, when you were tightening it up, there was so much slop in here, I was worried that it was causing things to get out of kilter. But these aren't the best collets, but they're cheap and inexpensive off of eBay. Now, I need to make sure I'm getting the right one for the drill bit I'm going to use, and I need to get a really tiny one for this drill. So where is the smallest one? Let's see. It's this one right here. Drop that back in. Drop that back in. Now, I'm going to insert my drill bit now. I'm not going to have to go very far, but, oh, I just dropped it. So, these tiny little drill bits, they drill really good holes, they're very sharp, but the problem is if you drop them and you don't find it, you will discover it at some later point when it embeds itself deeply into your foot, and that hurts. And I've done that, and you don't want to do that because it really sucks. That's why I pick these things up. Anything I drop, I'm going to pick it up right away just to make sure. Okay, so I'm going to go ahead and try and actually get it inside right now. but you're going to notice it's going to be quite long. Oh, maybe I had the right one in there the first time. I guess I did. Let's try that one again. See if I did have the right one in there. Just slightly bigger than the tiniest one. So I want to make sure I go far enough that it's not going to interfere with the motor mount or the motor shaft when I put it back into the motor. So I'm going to go about that far with it to where my thumb is. And then I'll just tighten it up a bit. Make sure everything's perfectly in line the way it should be. Looks good. Put this all back together. Whoops. Oh, see, I wasn't quite paying attention to what I was doing. I thought I'd screwed too far. Now I can't actually see what I'm doing, so I gotta put this down. There. There is a flat side on the motor, so you do want to make sure that you're lining that up correctly. Sorry, I think I just banged this. There. Now there is a flat side on the motor, so you do want to make sure that you're lining up your set screws properly. I'm usually a little more paying attention to what's going on, but you know. Make sure those are nice and tight. Give it a little test. Now, let's go back to the side camera here. With a long drill bit, and if this is collet or anything is out of a whack, just a little bit, you're going to get a wobbling. The tip is going to wobble, and it's really annoying. So, if you can find higher quality collets, go for it. But you know, go with what you can. Okay. Enough talking. Let's put this thing into some action. However, it's not going to work. You may notice this is really high. In fact, it's not even going to go all the way down. I can still get my fingers between the bottom of the bit and the bed, despite the fact that I pushed it all the way down. That's because, in order to make sure I could get all of the height that I wanted for even the bigger drill bits, what I can do is remove these spacers that I built into here. There we go. So these spacers give me the extra height I need in order to use the longer drill bits. But now that I've taken the spacers out, you can see that the drill bit is much lower. This up here is an upstop. So I'm going to slide that down. And now you can see if I actually want to drop my bit a bit, and I can lock this down. And then with just a screwdriver, I can lock it down. And that's my upstop. So I had a circuit board around here somewhere. There it is. I'm going to have to do it this way, I guess. Just tighten this up. There. So now the upstop has set it. Now, this is an incredibly useful feature because when you're drilling a whole bunch of holes in a line in your circuit board, I don't know if you can actually see that, you want this to actually be just above the board, you know, like right there. That way you can just go boom and then push down. You don't, and if you let it go, you don't want it flying all the way back up because that's just, you know what I mean. You'd have drills. So I'm going to move my guide a bit just so I can find a clean piece of real estate on this board. That looks good. Now, Now that that's set, I'm going to lower my guide a bit. Because I want this just above, right about there. Push her down. A little more awkward in this angle because it's not directly in front of me. Good enough. Good enough. I'm just going to tighten that up. You know, if I'm not trying to do this for the camera, this would be directly in front of me. You know, it would be mounted right here and I'd be set up to go without a problem. Now, interesting thing about drilling these circuit boards with these tiny little drill bits, they generate a lot of dust. Unfortunately, I don't have my vacuum cleaner here. So, which is probably a good thing. But I do need my garbage bin. Alright, so let's drill some holes. You know what, just so you know where I'm drilling, let's take a marker, we'll go with pink, and I'm going to drill them right along that line there. So I've made a couple of marks on my thing. Let's go to the overhead camera, that's why it's there, right? That might not be awesome. Now you can pick your speed with whatever drill bit you want to use or anything because it is PWM controlled. And there's my nice little alignment of holes. Let's see if we can go to the overhead cam. Can you see? I'll get some white paper over here. Sorry. Come on now. So it was these holes right here. The drill bit, one thing I will do is I will actually cut the drill bits down. I'll use my snips here and I will cut the drill bit down so that it's actually not, I will cut the shank. You can see on here the way I've mounted it. There's still a lot of shank sticking out, plus a lot of drill bits. So I will normally cut quite a bit of the drill off, the bit off, so that there's only about maybe that much of the drill bit sticking out of the collet. And that way it reduces the amount of wobbling that you're going to have. And of course, anything that you do like that will definitely help make your drill more accurate. So it all comes down to that collet, your drill, and your motor for final accuracy. But the drill itself is so sturdy and beautiful. Now I'm going to show you some tricks about how we actually build this thing. Hang on. Something has gone awry. Hey, I got somebody, well, hey, I actually have a viewer, so yeah, thanks. The guide actually does help a lot. Now, I originally did use a Dremel. If you were to search my channel, there's a video on there where you can see I was using a Dremel tool originally, but it wasn't that great. And using the standalone motor, I like this. I like this a lot better than actually using a Dremel because it's just a fully standalone tool. I can just put it off the shelf, take it out by itself and plug it in. No fuss, no muss. Now, let me see here. Sorry, I'm still new to this, as I keep saying. I'm not always on the right camera or whatnot. Now I've already used this quite successfully to make quite a number of circuit boards. And when you're making all those double-sided circuit boards, this really does make life a little easier, because when you're dealing with a 0.5 millimeter drill bit, this actually helps so much when you're making those tiny little holes. All right, so let's unplug this. The tubes that I'm using on this, these are carbon fiber tubes, and these are carbon fiber rods. Now, the reason why I chose these is I wanted to have the smoothest action possible for going up and down. Where's my... But I also wanted to make sure this thing was going to be very stiff. It wasn't going to wear out. And that I could actually make it long enough, with enough throw, to have the longer drill bits. So the only way to do that was to actually use it with the carbon fiber tubes. Now this carriage, the trick about this carriage and why it's actually so smooth, I'll switch to the upper camera. Let me switch to the upper camera. I don't know if you can actually quite see it, but inside this carriage, this isn't just a hole. This whole carriage is printed just as one block, straight up, so the holes are really beautifully made. But inside here is, in fact, another carbon fiber tube. It's another one of these. And it's actually press fit into the carriage block. So then, here we have the carbon fiber tube. This is called a P200, and this is the carbon fiber rod. We use these in the kite building industry to make spars with. These P100, 200, 300, 400, these are really popular spars due to their incredible flexibleness, but strength. The higher the number, the less flexible and stronger they really are. So the lower the number, the more flexible. And then we use these solid rods as what we call a ferrule. So if we have to join multiple tubes together, we'll cut a piece of this rod down to just a few inches. I gotta make sure I'm underneath the camera. And then you can glue one side inside glue it inside one, and then you can slide the other tube over and connect the multiple tubes. But the neat thing about these Sky Sharks is that they're made very well, very consistently, and they have an internal diameter of 0.244 inches. It's just about a quarter inch, right? The thing about these carbon fiber rods is they have an outside diameter of 0.240 inches. So you can see there is no slop. Well, there is slop, but there is like very little slop. If I had put that inside here, I can remember what camera I'm on. I'm very sorry about that. And I'm not sure I'm getting the right light to do this. There, is that better light? I don't know. Oh my God. So, one of the reasons why I'm having such a hard time is that one of the monitors I was going to use turned out can't. Did you say a 20-foot slide? Oh, that's a lot. Anyways, so that's the secret to why this carriage is so smooth, is these carbon fiber tubes, and I'll show you some links to where you can actually get this stuff and how these are actually made. The other requirement I had about this is that it has to be fully disassemblable. I want to be able to take it completely apart if I ever need to upgrade it or fix something. That means not everything can be glued together. So these carbon fiber rods, you'll notice that there's some sort of a cap on here, and on the bottom there's also these little bits that hold the rod in. Now it's easy to think that these are all just fully glued on each end of these rods. However, if I did that, I wouldn't be able to take it apart. You'd never be able to get this carriage off if these were in fact glued on. Never be able to get these springs off, or maybe if anything like that. So there's in fact a trick I used to make these rods removable, and I can actually take them apart, and I'm going to show you how that really works. Where is my demonstration pieces? Okay, so we gotta pop over to the computer now. That's what's wrong. Okay, hi, I hope you can still hear me. I've had to switch over to the computer. This is a little bit challenging doing everything by myself, running this YouTube channel. I didn't know what I was doing when I got myself into it. So first and foremost, what we can do, the drill press is available on Thingiverse. You can pop over there, search for KiteCraft, you'll find me, and then it's one of the things I build. You can go ahead and download each individual piece if you really want to. I recommend you go ahead and actually just download this file, this step file, because then you can just use this in Visual 360, make whatever modifications you want, because you're going to need to make some, and then go ahead and print this as you want. At the very bottom down here, you'll see another file that's called non-printable parts list. Whoops. This has some of all the stuff that you actually are going to need to purchase or source somewhere else that you actually can't print. I'm going to open this in a new tab. There we go. First of all, when it comes to filament, you can use any filament you want. There's no reason why you have to use anything. It doesn't matter. But what you'll see in a couple places, you're going to want to use a soft filament like a Ninja Flex or a TPU. And that includes places like the bottom of the bed. There's foot pads on the bottom of the bed that you can glue on. And it helps just to give a bit of traction to the whole drill press when you're on top of a surface. And then inside the motor mount, there's some soft inserts so that you're not crushing the tubes when you tighten everything down or you're moving the motor mount around. So those soft inserts should be made with a Ninja Flex. Now the carbon fiber tubes can be sourced from a place called Kites and Fun Things. It used to have a different name. If you come to the Kites and Fun Things site, you're going to go to carbon fiber tubes, pull-treated carbon tubes, or you can just search for this word, blems. Blems means blemishes. Now these carbon fiber tubes actually in the industry have a variety of uses, including, or maybe even more predominantly, arrows. These are used as arrows in the archery industries. But we also use these in the kite industries. Now when these are being made, they might have some sort of imperceptible flaw to them, and as such they're not like the highest quality that can be used. You wouldn't want to use these for an archery competition because of some specific flaw that might have been in there. So they're called blems, and you can buy them here. You can buy the unblumbed, normal ones, but they're fairly expensive. So come and buy these blems, and what you'll be looking for is these P200s. They have an outside diameter of 0.284 or about 7.4 millimeters, and that's what I've sent the design for. These are called P200s, and they're only about $2.50 each. And you're going to want to buy 2 of these. These are the carbon fiber tubes. Oops, make sure. That's these tubes right here. They form the inside bits of the carriage. They also form the center upright, the rear uprights, and underneath, there's actually 2 reinforcement rods underneath. These are used to help stiffen the overall bed, because I don't think it matters what, you're going to have to do something with a particular filament or whatever, but everything I tried, this bed was always too flexible. Sorry, underneath the camera. So you're going to want to use some strengthening tubes underneath. And that's where those P200s are. The other two, if we look back into the file here, is a solid rod actually. we just pop into this list. We are looking for the one that has an outside diameter of 0.24 right there, 6.1 millimeter. They come in at the length of 48 inches. You only need one of these. That's definitely long enough to do what you're going to do. And they're about $11 for, I think, that one. Let's see, 0.24. Yeah, it's about $11, but you only need one. So that's where you're going to source those. The other few things you're going to need is some screws and nuts and washers. You're going to need a motor, a 380 size motor with 16.2 millimeter mounting holes. Yeah, true. So I'm actually a kite builder, as by the name. A kite designer, kite builder. I've won a few awards with some of my kites and what I've done. And I will, in fact, be adding kites into my streams later on. So we'll be doing a whole bunch of weird things like that. Check it out. Anyways, back to so these PWM motor controllers. If you go to eBay and you just search for them, you'll come up with a whole variety that can be used. The one that I like the best is this one. The reason why is it actually has an off on the dial. Let me show you. So on this particular dial, I don't know if you can hear the click. So that click is an off position, and that actually turns off the current to the output instead of just turning down the PM. So you go click it, and now you're into the PWM range, and you can start turning it up. And this is a 5 or 10 amp. It's definitely sufficient for this particular motor, but it is in fact, and you gotta remember, this is cheap Chinese, eBay cheap knockoff stuff. So again, buy a couple. Who knows? One of them might just burst into flames on you. I do not sell these. I do not endorse these. I'm cheap. I don't have any money. Go ahead and check out my Patreon. You can, throw me a few bucks. Otherwise, this is kind of where you want to go for your motor controller. The call-outs that I was talking about earlier, again, you can source them off of eBay. Rather inexpensive, but they're low quality. Buy half a dozen of these. So just to make sure that you can actually get enough parts to buy one, to find one that isn't horribly off balance or off kilter. XT60 connector, as I showed you, you want to be able to plug this into both a power source and a battery pack. So do whatever you want for your own wiring. I like to braid everything. That's why you see my cables are all braided on there. The 30 millimeter fan is in fact optional. I don't know that this actually generates enough heat to worry about having to deal with a particular fan, but I did install a fan in here anyways, just in case. And it plugs directly into this, to the 12 volt in that way, the fan is always running. As long as there's power to this, the fan is always running. If the fan was connected to the outputs, then the fan would only run when this was turned on. And you don't really want that. You want to be able to have the fan running afterwards. The last little bit is this 3 millimeter hex shaft. These are those Tamiya kits. You can buy these at pretty much any hobby shop. Inside those kits are a hex shaft and arms, whatever. But you want to use the hex shafts out of these. And then last is the secret for the uprights, and this is 2 millimeter brass rod. So the brass rod is actually we use it as a locking pin when we make the uprights. Now these brass rods, you can buy these at any local hobby store, along with your motor and your wiring. Easy to cut. You want to keep it fairly straight, so don't go ahead bending these or any whatnot. These are in the piano wire sections at your local hobby store. You're going to need one of those. Again, not very expensive. So those are really about all the parts that you need that you can't directly 3D print. Okay, now let's go ahead and actually have a look at the model, and we can see what's going on there. Bear with me for just a moment while I switch things over. Hi, okay, we are back. So this is Fusion 360. This is actually what I used to design this entire model in. Now, if you're in the 3D, Thingiverse, you download that step file. You can actually just open that step file directly in Fusion 360. Up here in the top right corner, we can go to File, Open from my computer, and then just go ahead and open that step file as you downloaded it, and you'll be fine. It will open just like this. This way you can make changes as you need. For example, if you get yourself a different motor controller, you might want to make yourself a different box and a different, maybe you're not going to use a fan, or you can do something different. So you can actually just go ahead and find the motor controller, turn it off, or just keep that part and keep the mounts. I always recommend that you go ahead to Thingiverse, or you go ahead, find the original files and do what you can to modify them. I also recommend that if you're sharing files, make sure you share the step files to make it easy for people to modify. If you want to make your own, if you want to use a different motor, like a stronger motor, and I'll show you some options later, make any changes you want here. Just make sure that the center of this hole, let me turn off the motor. You want the center of this hole to be right where it is. So go ahead and put any new changes you want, but always make sure that where your motor comes out, that center of that shaft should be center of that hole. Now, once you've built your drill press and you built all of this and you put it all together and it's all wonderful and you turn it on for the first time and you put a drill bit in and you sink it all the way down, it's not going to line up with the hole. The hole is a little bit small, I get it. You can make it bigger if you want, but because of that, your drill bit might just be off to the edge of the hole, and that's just where it's going to be. Deal with it. So I'm just pouring in here right now. So let me show you exactly how these are actually built, these uprights, because they're the real trick to how this whole thing works. So let's go ahead and we're going to hide the lower mount. We're going to hide the upper mount. Let's get rid of the bed. I'll show you the jigs here. These pieces are really important to help you make these uprights, these jigs. And I'll talk more about them a bit later. But for now, let's just go ahead and hide them. Let's hide the spur here, wherever that is. We don't need the uprights either, or the handle. Don't need the drill bits, or the bed guide, or the brackets, or the motor mount. Let's get rid of the spring. I'll talk more about the spring. You can choose your own spring, and there's an easy way to make changes to the spring. If you want to make a different spring, let's just hide this spring here. Where'd it go? You can just make a different type of retainer. So if you have a look at how the spring, and I'll show you this on the big one. Where's the spring again? I just lost it. You can see that the spring just sits right into this retainer, and then that's on both ends. And if you want to use a different size of spring, we can just make a different size of retainer. And then we'll hide that spacer. So these are actually little inserts with a threaded cap on them. If we actually go in and hide these cap screws, or these cap nuts, there's one. There's the other one. You can now see what those actually look like. In reality, this is what they look like. So you can see that they're hollow, where they'll fit into the tube, and they have some threads on them. The longer one has a hole in the side, and that's the secret right there, is that little hole. When you print these out, I'm going to switch back to my other camera now. Samsung, yeah. Okay, I think. So when you print these out, they're going to be a very tight fit. You want to make sure that I don't want to have any slop in there. So everything's always printed just slightly smaller than you're going to need it. That's in order to make sure that you do a little bit of filing in order to get everything to fit properly. So I'm going to pull out my files, find the right file that I need here. I want one that's slightly rounded, not the full round one, but the half round one. Where is it? No. Oh, there it is. It's on the end. Come on now. There we go. Nope, it's not that one either. What? I'm going to be missing the drill. How can I be missing my files? There it is. So we're just going to file the inside of these a little bit. I hope you can see what I'm doing here. Maybe I should switch cameras. So I'm going to file these down until I can actually, I did have the wrong one. I want this one. Just keep going in circles all the way around. Make sure you get a nice file, even check it every now and then against your carbon fiber tube. You want to be able to push it in, just a little bit of resistance. Okay, you don't want it sliding off or sliding on or anything. There's no slop. So it should just take a bit of filing, and you want to push it on to one end, just like that. Make sure you check the other side as well. Nope, got to do a little bit of filing there. There we go. So now that we have those, we've test fit those, we've made sure that they're good. Let's just make sure that our end caps are going to fit right. Get in there. Did I print the right end caps or the cap nuts? Yep, I did. So you just want to make sure you work it around. Good enough. Okay, good. Yep, got the right ones. Whoa, gonna lose it. So now what you'll notice is that on the top, you've got the short one, and on the bottom, you've got this long one with the hole. You're going to cut all your spars exactly the same length. The measurements are in the drawings there. Let's just have a quick look at what those are. So real quick, we'll just have a look at the length of those. I got to make sure I get rid of the bottom hardware so I can see. No, there. Click there. There. If we look at the bottom right corner, you'll see that these are actually 219.5 millimeters. Now you want to cut these a bit longer, so you actually want to cut these to be about 22 centimeters long. 22, maybe 22.2 centimeters long. Cool. Yeah, Fusion 360 is so powerful, and you can edit pretty much anything in there. And I love it when people are actually sharing editable files, not just the STL files, because it's always such a pain in the neck dealing with just STL files. So I'm always encouraging people to use step files as well. So you want to cut your spars to be about 22 to 22.2 centimeters long. We want to make them just a little bit longer than they're finally going to be, and we'll sand them down afterwards to make sure that we actually get a really nice fit for everything. Oh, sorry, I was probably talking to the wrong damn thing. So you want to cut these spars to be about 22 centimeters long. Now, on one end, one of these days I'm going to bring the right thing with me. on one end, where you've got the short bit, you're going to use a little bit of CA glue. Now, first of all, of course, go ahead and print all of the hardware, all of these little inserts, all of your cap screws. Get everything printed, get everything filed, get all of your spars cut, get everything ready, because you want to do each of these all at once. So go ahead, get your CA glue. You're going to put a little bit of CA glue on the end of, use it like a medium CA glue. They dry pretty quickly, so make sure you're ready. Put a bit of CA glue on there, and then go ahead and push that on and make sure that it's nice and flush. And then boom, that whole thing should be dry. The end of your carbon fiber tube will be flush with the end of your 3D printed part, and that's all you needed to do. Now you'll notice this will actually fit perfectly into the holes in this top plate. And once that goes through the hole, you can actually just put your washer on and then screw on your cap screw. So that's how the connection to the top is made. Now, like I said, these are actually glued on, so those are permanent. The other side, we're going to use a trick with this 2mm brass rod. These holes are about a 2mm hole, and if you look, we should just be able to force this 2mm brass tubing into it. We'll probably have to hammer it later on, but that's fine. You don't want to drill these out too much. You want this to be a really tight fit, so that's good. This is going to go on the other end. And we're going to end up drilling a hole through this carbon fiber tube, and we're going to cut some of these 2mm brass rods down into little keys that will be pushed into the hole and through the hole in the carbon fiber tube, which will lock this insert on. That way, when we actually want to take this apart, we can actually take these off, slide our carriage on, slide these back on, put our pins in, and we can go ahead and seal this down onto the bottom. And it's all about those pins. And that's where this jig comes in. Because you're not going to be able to get this stuff to be accurate enough without a jig. All of these rods, all of these uprights, I'm just going to switch cameras here. So all of these uprights, with all of these inserts, the spacings here all have to be exactly the same on every one of these rods. It has to be absolutely perfect. If it's not, when you tighten these down, it's actually going to cause it to kink and to warp a little bit, and that'll cause this to bind a little bit. And if these are not perfectly in line, this will bind. Trust me. It took a lot of work and effort to get everything perfect. It has to be perfectly even on every single one of these 5 rods. It's actually easy to do. In the bottom corner of that Fusion 360 drawing, you're going to see these 2 little blocks. They look like this. Where is it? Nope. Hang on, I lost my camera. See, where was it? So there's jig 1 and jig 2, and they look like this. This one has a slot and a hole, and this one just has a couple of holes, plus and minus, and the tiny little holes on the top. You need yourself a dowel. This is a 3/8 inch dowel, wooden dowel. You're going to take the jig with the 2 slots in it, put it onto your dowel, and just glue it onto your dowel, right on the end of a dowel, just like that. Go ahead and glue it down. Make sure that the slots are on the outside, away, and you want the stick coming onto the inside. Go ahead, before we actually do that, once this is glued and all your glue has set, once all your glue has set and this is on there all perfect and wonderful, take your second piece and make sure that the plus and minus are lined up with the plus and minus on here, and that they're together. Go ahead, put it on your dowel. Now your dowel is 22 centimeters long. We need to set this block, or we need to actually set a dimension here to be exactly, let me just check. What we're actually going to do is we want to take a measurement from, let's get rid of all of our hardware. No, let's put our hardware back. Get rid of that top plate. Where is it? So we want to measure from here. This is the outside edge of that flange, all the way down to this hole down here. Oops. And we are looking at exactly 194.2 millimeters, so 19.4 centimeters. So keeping this flat on your table, go ahead and measure with your ruler from this outside edge of the flange here, of the slot, from here to the center of that hole, about 19.4 millimeters. Or 19.4 centimeters. There. Now you're going to put some effort in there to make sure that it's perfectly set up. Go ahead and make a mark with your pencil so that you can come back to it. Now you want to go ahead and glue this piece onto your wooden dowel. Get it nice and lined up as much as you can. Have those both glued on there is perfect, and that's all you need to do. Now you're going to need a regular drill press or a hand drill that you're going to be vertical with, because remember the earlier step we glued these on. Now this tube would normally be longer, so I'm going to go ahead and shorten this just for the demonstration purposes. But you're going to take your tube and you're going to push it into your hole, and then make sure that it pops into the slot here. There you go, just like that. Now you know exactly where you're going to be drilling your hole. So go ahead, put this in your regular drill press with a 2 millimeter drill bit. Drill straight down and through the tube, and go ahead and drill all 5 tubes. So you've got the different slots here. You got this is for the bigger tube. I should have actually had it this way, or this is for the bigger tube, and then the smaller tube actually goes into here. You want to make sure you're using the right hole, because if you try to use the smaller rod inside the bigger hole, you're not going to get this vertical hole drilled correctly. So that's exactly how you go ahead and you make these uprights to get everything all perfect. It's just that little bit of a trick. That's going to drill a nice hole through the side of your tube that you will then actually be able to come back with. You'll be able to line it up just by a little bit of effort and shining a light through. Take your 2 millimeter rod, push it all the way through. You'll want to use a little hammer to tap it in. Use a bit of a file in order to file the edges so there's absolutely no part of the brass rod sticking up, and it's all flush, and it'll fit into the hole perfectly. And then when you put these caps on, finger tight only. You do not need to wrench these down. All you need to do is just keep everything finger tight. Nothing needs to be more than that. We can actually just pop them off, and you can just see how that all went together. There's my washer. That's how you're able to use these carbon fiber tubes and get such a very strong, stiff frame while having this perfect, smooth action. It's a really wonderful design that I'm quite happy with. Anyway, so that's the big bits about my drill press. I don't think I want to babble too much longer. Let's have a look to see if there's any chat going on. So True Tech, other viewers, True Tech, I want to really appreciate your viewing and chatting. I am entirely new to this whole streaming bit. You're like the second person ever to chat, so that's awesome. Thank you very much. I'm going to have to move my camera again because I keep forgetting what I'm doing. Bear with me. Bear with me. Don't go away. So my camera's a bit low, whatever. So this is my drill press. Now this video is as much of a practice and a test as it is anything else. I'll probably end up redoing it. I've learned a lot. That's the trick to making these uprights. The rest of it is just fairly simple. Just go ahead and print it out and slap it together. The biggest part to print is, of course, the bed. Now, once you've printed the bed, you're going to want to go ahead, cut some lengths of the carbon fiber tube, the P200s, and you're going to want to glue it inside these holes that are inside the bottom. Now, you're going to want to, this is a little challenging, you probably want to use an epoxy glue, not a CA glue, because the CA glue sets too fast. Use an epoxy glue. But you want this tube to be glued into every single block, not just the end blocks. You need the tubes to be glued on every block. The reason is that's how we're going to get the added stiffness from this. If we actually only glue the ends, we're actually still going to be able to flex this a bit because the tube will slide inside these blocks. Even though it's solid on the end, we'll actually still get flex. By gluing it solid into each of these blocks, we've eliminated its ability to slide, and boom, we lock it in there. We're going to get a much stiffer bed that way. And it is important to get a nice stiff bed, so you're going to be using the tubes in there. I used a TPU, a TPU filament. That's what the black foot pads on all of these. CA glue, when you want to glue like Ninja Flex or TPU to PLA, or you want to glue anything to PLA, just use CA glue. A medium CA glue is wonderful with PLA. I have mine right here. This is a mercury adhesives. This is exactly what you want to use whenever you want to glue anything to PLA. So all of the foot pads are glued on with PLA or with CA glue. That just keeps it, that really does just give it a little bit of extra grip. If it was just straight PLA, it'd be really slippery on this table. So that TPU just gives it a bit of grip, which is really nice. Go ahead, check out my Patreon. I'm still new to this. Any money I manage to raise, I'll be using to actually buy a new webcam, because as you can tell, the webcam I'm looking at sucks. And the other cameras aren't quite in sync, and it's all kind of weird. Isn't it? Is it sounding weird? Anyways, you know, if I manage to raise some money, I'll buy a webcam, and then I'll also pay rent and maybe buy some food, who knows. The next project coming up is actually going to be sled kites. I'll be sewing some sled kites and showing you how to do some quick and simple applique work. So if you want to take, if you have friends and family, you want to go for a work picnic or something, these sled kites, because they have no sticks, they fold up really quick and easy. You can just throw them in your pocket, and then when you're out, you can actually just take them out really quick and throw them up into the sky. Kids love them because they're so, the tails that you can put on these are just wonderful, and kids will run everywhere with them. And they're great practice for creativity because there's no sticks, and it doesn't take a lot of fabric to make one. You can actually make a lot of these just using up scraps of fabric. Take them with you to the park, or when you're out for an office party or whatever, like I was saying. Give them to your coworkers. The sled kites are a really versatile, wonderful kite. It can almost be used as a calling card. So I'll take you through on our next project night some quick and easy ways to build templates, solid templates that you'll be able to reuse over and over. Even though they're made from poster board and tape, you'll be able to hot cut against these templates over and over and over, and that's really useful when you want to make a reusable kites. Now, overall, I'm pretty sure this video was horrible, but I thank you for watching. Check out my Patreon on Twitter, KiteCraft1. Somebody else already got KiteCraft. Screw him. And go ahead, build yourself a drill press. Thank you for watching. Where's my... I lost my mouse again. I hope you enjoyed the stream. What's going on over here? Yeah, lots you can do with flexible filaments. Okay, well thank you all for watching the stream. I'm going to have to book out. It's been my hour. I'll probably be back on in a little bit maybe. I might be playing Mist later, or look for me tomorrow with Mist, or the next project stream with kites. Bye now.
Shut up and sit down.